At Service Logic, we believe the future of the skilled trades lies in training and development, and that's why we created the Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is the Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been pretty good experience, especially my second year students, and the light bulb kind of syndrome goes off when you see that little flicker in their eye and they're, oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
Hello, everybody. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. Boy, there's quite a few exciting things that I'll be sharing with you today. Let me know in the chat how the audio is sounding. I'm going to use your input to help guide the audio and video design of this new studio. So there's so many things to share. Got a lot of progress done this week. So one of the things that we're going to be doing is we're going to start utilizing more of our hands-on training. That's one of the things that we've mentioned before, and that is going to be a very important thing going forward. So our good friends over at Johnstone Supply, the Grimmy Group, actually provided us with a modulating gas furnace that we're going to be using. I'm going to use some of the other cams for this week, and our sponsors this week are Daikin Comfort Technologies, Service Logic, Hudson Technologies, iConnect, and the United Association. So hello, everyone. So that's one of our auto tracking cameras back there. But one of the cool things about our auto tracking cameras is I can pre-build scenes for them as well. So like with this particular one, we can zoom over and look at that. So on the right-hand side is a modulating gas furnace that I put together yesterday. Oh, fantastic, Renee. I'm glad the audio is coming through fine. I got another one. I'm going to try the headset here in a little bit, and then I'll see what everyone thinks about that. So when we start talking about gas furnaces, I love tearing gas furnaces apart and putting them in front of us so we can actually see what's going on. And I'll be over there doing some hands-on demonstration here in just a little while. So what we did was that gas furnace that was donated by Johnstone Supply, it was one of their scratch and dent, but all of the controls were still fully functional. So yesterday I spent the entire day building you a modulating gas furnace so that we can discuss what modulating gas furnace technology is. Paul, oh, so glad that you're joining us, Paul. I think you'll really enjoy this one because we can talk about some of the 80s because that is a 80% Goodman single stage furnace on the left. I put that together back in 2018. And then the one on the right, it is a 97% modulating gas furnace. And they're very misunderstood in our industry. So when we start looking at modulating furnaces, I think it's important for us to look at all of the different modulating gas furnaces that are in the industry. We've had a progression for the last 2 decades of modulating gas furnaces. We've had them for 20 years. So when we look at where we are today, it's important to see where every manufacturer is at. And I think I've got pretty well everyone covered today. There might be some that aren't. Well, hopefully I'll get them all covered. I'll at least have the design, the principles taken care of for us. So let's talk about modulating. And for everyone joining, I'd love to know where you're joining from. Paul Leonardi is in South Jersey. And let me know in the chat your experience with modulating gas furnaces. Are there particular brands that you like? Are there ones that you've had difficulties diagnosing in the past? Because hopefully I can cater to, if not all of them, most of them today. So let's dive right in and talk about modulating. Well, when we talk about modulating, we're talking about gas furnaces that have a varying capacity. And in that social post that I put out, I said that they are, to me, they're the inverter of the gas burner products. And the reason I say that is because we are actually doing algorithms. We're doing calculations to be able to stage up and to stage down, just like we do with a inverter, air conditioner, or heat pump. So, Katie, that's cool. This is what I'm hoping for because not a lot of people have experience with modulating and they're becoming very popular. One of the things that we're going to be seeing, Jason Objute called me today. We've been tracking legislation about the phase down of single stage gas furnaces. And it looks like we are going to be going ahead with that so that by 2028, it will be high efficiency condensing gas furnaces only, which means we're going to have a lot of modulating furnaces out there. So let's spend a little bit of time understanding what a modulating gas furnace is. So if we look at different brands, we're going to bounce around through different manufacturers. And if at any point along the way you have questions, you have concerns, things you want to dive deeper into, you just let me know because I'll stop and we'll try to discuss them because I've got experience with most of these manufacturers. And it really comes down to the modulating design has 2 primary types of control. And when you understand how those work, you'll better understand the entire modulating gas furnace industry. So let's start with the York brand. So this is our Johnson Controls products. Their model for this particular one is the YP9C. And this one is a 97% modulating, I think that one's rated at. And it can modulate its capacity between 35% and 100% of its rated capacity. So you've got a 60,000 BTU. Well, that 60,000 BTU will run all the way down into the 20s. It'll run 35% of that rated capacity. But how does it do it? And does it matter if I'm on a legacy thermostat or a communicating thermostat? And it does. And we're going to talk about both of those strategies. So we're going to go through all of them, and then we're going to focus on a wiring diagram for the one that I actually have here in the studio. So the one in the studio is a Goodman 97% modulating, and it does have the communicating platform that I love discussing, which is called the Comfort Bridge platform, which allows us to use a legacy thermostat and a communicating outdoor unit. It's a really cool scenario. Hey, Scott, I'm glad that you're joining us again. I can't wait to come see you. I promise. We're going to put that on the schedule when we head over to Ohio. All right, let's take a look at this York. It lets us understand the design when we dive into the wiring diagram. Let me see if I can blow this up a little bit more for you. If we look at this furnace, right? It's a modulating gas furnace. Let's take a look at some of the controls. If we look at the integrated control board, actually, let's blow this up. See if we can get it even better for us. And Yeah, I'll be fine down here in the bottom for now. All right, if we look at this control, you'll notice that we've got, if we go up here and look at the motor, up in the top right. Oh, I should be using this on the smart board. When we get to the Goodman, I'll actually use the smart board and we'll go through the wiring diagram on the smart board. So if we look up there in the top right where it says MOT, that's our motor. And then if we look at the plug, we'll see real quickly what type of motor this is. So we've got our main power on the left. That's at 1, 2, 3, 4, 5. So that's our high voltage incoming power. And then we have our 16-pin connector on the bottom. And if we look at those terminals, we know real quick, this is a ECM constant airflow. This is a true variable speed motor, which many of our modulating, I would say, I think all of our modulating are a true variable speed. Now, when we start looking at the strategy, and here, let's take a look at this real quick. When we look at these two different furnaces, let me go to the side so you can see all of it. If we look at these two different furnaces, I tried keeping them relatively similar so that you can look at it and go, oh, wow, they really are very, very similar. We just have a little bit more wiring. So if we look at the unit on the left, it actually has more components because it has that A2L refrigerant control board and sensor. But we have a main control board, we've got a transformer, we've got a draft inducer, we've got a gas valve, we've got a flame rod, not a sensor, it's a rod, path of electricity, passes through it, doesn't detect, it's just a path. We have a hot surface igniter, and then a fan. So this particular one, I just threw a shaded pole motor on so that we can keep it lightweight and portable. In this modulating gas furnace, really take a look at it. There's not a lot of difference. There's actually almost no difference. We just use some different control logic. So we still have our main control board here in the middle. We still have a 24-volt transformer. We have a draft inducer. Now we do have more pressure switches on this, and I'll go into that as we get into a little bit deeper into this. And we got a gas valve, but then we got our flame rod, and we have a hot surface igniter, and our PSC motor has been replaced by a ECM. And so hopefully, as I get a little deeper into these ECM boards, I'm going to have a functional rotating display so we can actually see the sequence of firing on those 3 poles of our motor. Not quite there, kind of ran out of time today trying to get this whole studio prepped. Yes, I did get your email, I promise. We'll get in contact. So really, mechanically wise and electrically, they're very, very similar. So let's go dive into these things. If we look at that motor, MOT, variable speed, let's look at our other components. This is one of the most intriguing furnaces that I found going through all these different manufacturers because I actually found something that I hadn't recognized before. This particular one, see this IDM right here in the middle? That's our induced draft motor. And if you'll notice, that is actually a 120-volt draft inducer. So it is not a variable speed draft inducer. I sent some emails out to some of the York technical trainers because I want to dive a little bit deeper into that because I'm very intrigued with it. It's the only one that I found that uses a single speed induced draft motor in the modulating gas furnace. Now let's go look at the gas valve. Up in the top left, we're going to see gas valve. And if you look, you got TH and TR. Well, anyone that has worked on a gas valve before knows that's probably going to be a 24-volt AC signal. That's going to be operating our solenoid. But then we have our RXD, TXD. Those are going to be communicating signals. Those are going to be a variable DC voltage. So this particular gas valve can stage up and stage down, very much like our inverter compressor or our ECM motor. It can go in increments up and down to be able to proportion how much, in this case, flow we need going through that. If you think about an electronic expansion valve, what are we doing with electronic expansion valve? We're using our stepper motor to open to allow more refrigerant through, and we're using our stepper motor to close it back down to block off our refrigerant flow. Very same kind of principle in the modulating gas valve that is using that variable voltage, DC, to be able to control its position. And that is a really common gas valve used across our industry. So our modulation is actually happening at the gas valve on this particular unit. We've got pressure switches. They're not variable pressure switches. They're just simple, normally open, normally closed switches. You'll see on that, you'll find our PS1 just below the gas valve. There's PS1 pressure switch, ROS 1 and 2. That's our rollout switches. PS2 is right there. Right above it is LS. That's a limit switch. So if we've ever worked on a gas furnace before, that all looks standard to us. The gas valve has got a little bit more control, but all of our rollouts operate the same. All of our pressure switches operate the same. So really, it's a lot similar to our standard single stage gas furnaces. This particular one uses an external pressure sensor, which is really cool. It's actually monitoring pressure. So it's grabbing vacuum to be able to monitor what type of flow we have. So you'll only see, or I've only seen this particular function with the external pressure switch on this York. But when we look at it, it looks like a standard single stage furnace, except for the fact that it has a variable capacity gas valve. Wouldn't you agree? Looks like a variable speed furnace. Paul, we're actually going to go take a look at that. So it is a step. So I'll show you on this Goodman that we have, when it actually receives power, you'll hear it stepping. It is a true stepping motor. Now, how many steps? I am not the person for that. That's a great question, though, and I will dive deeper into that. I don't know if I doubt we can count how many are on that one. We'll see. Okay, so what does it use for a gas valve? It uses a modulating gas valve that has the AC voltage, typically 24 volt AC, and it has the modulating DC signal as well. So this particular gas valve is very common in modulating gas furnaces, because that's where our modulating capacity is actually happening, at the gas valve. But it's not the only design that's out there. This is actually the newest, I would consider this the newest generation of the modulating gas furnaces. Right? So it does still use a diaphragm. It's just pushing against the diaphragm. So it does still have some control. Think about like a thermostatic expansion valve, where we're actually putting pressure against our diaphragm for control. That's really what we're doing. I need to tear one apart and see what the seat looks like. We've been spending a lot of time talking to Residio here recently, and I bet I can get a spare one to tear apart so we can see what the inside of that looks like. That's a great one. We'll do a gas valve teardown class here in the very near future, since it is heating season. We need to do that. Great point, Ray. Thank you. All right, so let's move over real quick to the Armstrong. This is a 97. This one is a really cool furnace. It actually reaches up to like 98%. So it's an A97 MV. Now, it doesn't have quite as much capacity. It goes from 40% up to 100%. Now, let's take a look at it and see what it uses for its strategy. Because this is a really important one to understand, because it's the foundation for almost all modulating gas furnaces. This technology has worked so well, some of our manufacturers have never really changed the theory. Some, like the previous one, went to that variable capacity gas valve that's driven by a DC signal. But there are a lot that use this style diaphragm gas valve. Good call on that, Ray. So let's take a look at it. If we look at their wiring diagram, right in the middle, you have B3 indoor blower motor. Now looking at that, I can see I've got my 5-pin connector here on the left. That's our high voltage. We've got at least a 6-pin connector. It's probably a 12, but it's got no, this one is a 6-pin. This is a newer generation of the true variable speed. So it is using a true variable speed blower motor, right? This is an ECM constant airflow. Let's take a look at the draft inducer. If we go all the way over to the left, we'll see combustion air blower motor. Now, when we look at that, it has a variety of terminals, doesn't it? So we've got voltage coming in on purple and red, which are closed from switches. That's high voltage there. See that? Up in the very top, door interlock goes through the line, comes down through K4, goes over to K1, which has normally open and normally closed contacts. That's feeding power into that blower. And then here's our neutral side. So with this particular one, we have multiple speed. But if you look at the gas valve, over here on the right where I've got the red circle, MV, that gas valve, let's look at what it's using for power. It has yellow, which goes over to common, and we're on the low voltage side of the transformer, the 24 volt. So we have the common side of 24 volt, but let's follow that. MV goes up through that MVL, comes back down through the pressure, plain old pressure switches, goes through the pressure switches, goes through the S10 switch, goes down to that blue wire, comes back on S47, goes through RO out, and we're back at 24 volt hot. So this gas valve only has 2 wires, and it's 24 volts AC. So it has to be a diaphragm style valve. Well, how does it modulate then? And this is the other style of modulating gas furnaces. It's the original design that we started with. So how it actually operates, that was a variable speed draft inducer. Now, with this gas valve, you notice it's got 2 ports down here. I'll show you another iteration from another manufacturer that has better detail here in a little while. But we actually have pressure ports on this. A primary up there where it says do not adjust on the top with the little blue cap, and then 2 down here on the base plate. So it is a solenoid operated 24 volt AC gas valve, but its diaphragm uses pressure to control the gas. So we have a vacuum line connected over to our negative pressure of our draft. So either on the draft inducer or on the heat exchanger, sometimes it uses both pressure switches to be able to see where we are, because one of them's going to close in low, one's going to close in high. And the diaphragm is modulated by vacuum. So the faster the draft inducer goes, the more gas it allows in. So the draft inducer is the primary control for modulation. Isn't that interesting? Gas valve, plain old 24 volt AC. The modulation is being done by vacuum created off the draft inducer. So it uses the draft inducer to modulate how much fuel can come through the gas valve. And so if I have any problems with my draft inducer, if I have any problems with the vacuum lines from my draft inducer to the gas valve, or I have any problems with my flue pipes, I can actually change the capacity of my furnace because it needs to flow properly. And so our earlier generation, one of the things that we found a lot of was the vacuum hoses before we went to our current material, they cracked over time. And so we had a problem with modulating furnaces not proportioning properly, not modulating properly. They got a bad reputation, and it really was because of the type of material we were using for our hoses. That's why so much of that has changed, and the new hoses almost never rot out. But that's what we're doing with this particular one. And this is a brand new version of this furnace. We're going to go through a few different ones. All right, let's take a look at the Carrier Infinity 98. And if anyone has any questions, please hop in. This is a great topic for us to discuss. All right, so the Carrier Infinity 98, it can modulate between 40% and 100%. How does it do that? All we got to do is dive a little closer from the wiring diagram. And all of these pictures, all these photos, the wiring diagrams, these are right out of the installation manuals. I tried to find the most current installation manual for every one of these models, except for the last one, because I wanted to show you how and when it changed. All right, so let's look at this. Right in the middle, BLWM. That's my blower motor. And if I look at that, I go, oh, I got high voltage and I got low voltage. So that's obviously an ECM, constant airflow. If I go right above it, I see IDM, and that is induced draft motor. Now, when we look at that induced draft motor, you see that there are two sections to the plug. You have PL16 on top that says 1, 2, 3, PL11 on the bottom that says 1, 2, 3. So the PL11 on the bottom of the induced draft motor, it is white, black ground. So that's 120 volt hot. And then we have 1, 2, and 3 that comes back onto the control board. So our induced draft motor is a true variable speed as well. So variable speed blower, variable speed draft inducer, all of our pressure switches right above it, plain old pressure switches, LPS, low pressure switch, right? MPS, middle or medium pressure switch, and HPS, high pressure switch. It just has 3 different settings so that as our draft increases and our vacuum increases, it has 3 different ranges that it will actually operate. Helps it know how much air we're actually moving. Let's go over to the gas valve. Upper left says GV. So it has 4, 3, 2, 1, and 5 on the left-hand side. And by looking at that, I'm seeing 2 windings on it. So it's probably our DC motor, right? It's got a variable signal to it. So when we look at the gas valve, there it is again. So we're really only going to see these 2 iterations. We're going to see a modulated gas valve that operates on vacuum, or you're going to see one that operates on that variable DC voltage. So the reason I like to refer these as the inverter of fuel burners is I have a variable speed motor, a variable speed draft inducer, and a variable capacity gas valve. And it's being driven by runtime. We're going to get into that. I'm actually going to go through some algorithms with you to show you how they do the staging up and staging down. But it is a true variable in all aspects, from the blower to the draft inducer to the gas valve. This particular one, all of them are variable capacity. Okay, let's take a look at train. So this particular one is the XC95M, still modulating gas furnace, has a capacity between 40% and 100%. Let's see how it does it. Now, wiring diagrams on a lot of the train manuals are not the funnest, but we can sort through it. Let's take a look. Well, let's start right in the middle to the right. You'll see ICM, indoor fan motor. Really hard to see. I blew this wiring diagram up as much as I could, but it was still very difficult to see. But we can tell that we have 1, 2, 3, 4 on the right-hand side. We have the 1, 2, 3, 4, 5, 6, 7, 8, 9 coming across the left side that's using 1, 2, 3, 4, and 5. If we follow those back, we know white. We can follow black. So there's high voltage. So I got high voltage coming in on number 4, number 5. And then I've got my multiple taps over here on 1, 2, 3, 4. It doesn't tell me a DC voltage for this. We're going to probably assume that 1, 2, 3, 4 is going to be our variable DC voltage for the blower motor, making it a ECM, constant airflow, true variable speed. And let's go right above that. And it's even going to tell us in the wiring diagram, it's a variable speed inducer drive. Right? So it's our variable draft inducer. It's got high voltage coming in. It's got low voltage coming in. Oh, Ray, that's a wonderful question. Do you still have the ports to check the gas pressure, and are they set at low pressure gas compared to high pressure commercial? Yeah, so they're all in residential set at 3.5 inches, and we do have test ports on both of those. There's actually some instructions. I think I've actually got a slide in here where it shows us how to check that. But if you think about it, like if I was to check the running capacity of a inverter heat pump, I just simply run it to 100%, and that should be my total capacity, right? Same thing with a modulating gas furnace. We put that in heating test mode. It runs everything to 100%. And now I can check the pressure on my gas valve, just like a single stage gas valve. So I'm saying these modulating gas furnaces aren't as scary as many people make them out to be. When you understand how they operate, they're really not that bad. They're more like a single stage than they are too. Now, so we got a variable speed blower motor, variable speed draft inducer. Where's our gas valve? If you follow over to the right, the bottom side of the wiring diagram, the gas valve is over there. It has a blue and a red wire, number 1 and number 2. So this is on our low voltage side. 2 wires. Anybody have a guess of how we modulate this gas valve? Remember, if we just have 2 wires, it's probably 24 volts AC. And it uses vacuum once again. Oh, Ray, absolutely. Bring on the questions, my friend. We're here to help you understand this, right? Whether you're an educator, whether you're a technician, you're an engineer, we're here to make things understandable. Like we pride ourselves in taking installation manuals and rewriting them with crayons. That's the goal, so that we can all understand it. Otherwise, it's a bunch of scribbles. It's hard to interpret. I like reading them. I'm not super keen on reading books. I mean, I do read books, but it's not like my passion. But wiring diagrams and installation manuals, that's how I've made my career. I love reading installation manuals. It tells me everything that I need to know about a piece of equipment, even how it operates, just like this. So we're back to that other scenario. It's another vacuum modulated gas valve. Vacuum lines run up to the draft inducer, variable speed draft inducer. It's the primary control. Okay, let's look at the Rheem R98V. This thing's a monster. It's like 98.5% efficient. I mean, it was one of the highest rated efficiencies that I've seen out there. So 40% to 100%. That's its capacity range. Let's look at the wiring diagram. And they're okay. I would like to see Rheem and Trane have a little bit more defined wiring diagrams, and at least for a technician or educator perspective, just because it makes them so much easier to see if they're clear. But we can sort through this. Let's look at IBM right in the middle, right off the main control board. That's our indoor blower motor. And you'll notice on it, it has a 4-pin connector. It has a 5-pin connector. So that's a true variable speed, another constant CFM, constant airflow. Let's go over to the induced draft motor, top left. I see 1, 2, 3, and 4. And so I've got black, red, white, and green. Now, all my pressure switches, low pressure, high pressure, got 2 high pressure, over temp, those are like rollouts, then your main. Let's look at the gas valve, bottom left. So the gas valve, 5-pin connector. Any guesses what system that is? Right? Variable speed draft inducer, variable speed, and I'm assuming that's a variable speed draft inducer. It could be a multi-speed. It doesn't say in particular, because when you follow 1, 2, 3, 4, that's black, red, white, and G for green. This could be a 2-speed draft inducer. And actually, looking closer at it, it most likely is a 2-speed draft inducer. Well, how do we modulate that thing? Well, remember, it's based on how much gas we want. Is the draft inducer driving it, or is the gas valve driving it? Once again, the gas valve is driving it on this style. So that one looked like it had a 2-speed draft inducer, but it has a variable capacity gas valve. Same one, really. Okay, let's dive a little deeper. No, there's a bunch of them in it. And I'm glad everyone's still hanging in because this is a fun one. Like I said, I like doing this one solo. I know there's a lot of great trainers out there that would have helped us out from the manufacturers, but I wanted us to look at different manufacturers. So instead of having 10 different trainers, I thought I'd just run at this one myself. It's one of my favorites. Okay, this Linux, same way. This is another monster, rated at like almost 99. I think it's 98.5, but almost 99%. So this is the Linux SLP99V, 35% to 100% capacity. Let's look at its wiring diagram. This is only half the wiring diagram. I blew it up so we can see things a little bit easier. Well, let's look for our blower motor. And indoor blower motor over on the closer to the bottom right. Indoor blower motor. I have a separate module and a motor. So it tells me almost immediately that is an ECM. Now look at my power, 1, 2, 3 on the left. Oh, that's high voltage. And 1, 2, 3, 4 on the top, that's going to be probably DC voltage. So this is another true variable speed. So it's constant airflow. If we look at the combustion air, the induced draft motor, that's B6 over on the left, combustion air inducer motor. If I look at that, I have black, red, white, and then orange with the yellow stripe, coming down to ground. Well, looking at that, that's looking like, take a look at that box right up above that. So you go combustion air induced motor, go through the 1, 2, 3 for the black, red, white. That looks like a set of switches to me. That looks like any thoughts? Integrated gate bipolar transistors, maybe? So I have a 3-phase combustion air inducer. So I have a true variable speed. Just like our 3-phase windings in an inverter compressor, I've got standard 3-phase windings for my combustion air, which means that's a very important. Yeah, you're right, Todd. I think I jumped in there a little too soon. It is. It's all it is a 3-phase motor, which means they put a lot of work into managing the capacity of that draft inducer. Right? That's a lot of circuitry. So what kind of gas valve do we have? Oh, looky there. In the middle, GV1 gas valve. Common and MV for main valve, which means it is that same gas valve. I like these pictures because it's got the pressure stubs on it. It shows us negative and positive pressure. It's the same gas valve, the same pressure operated gas valve. Remember, I'm putting all of my control into the variable speed draft inducer. That's a 3-phase one. So they have a lot of control on that ECM. And so it's managing the capacity from vacuum operated off from the draft inducer. Like I said, all of these follow one or the other strategy. I really like their installation manual because it actually shows us how to measure the pressure. So Ray, earlier we had asked about how do we check the gas pressure. You can check the manifold pressure. We still have a manifold pressure port, so we can check the actual fuel coming out. Should be about 3.5 with natural gas at 100% with it running at full capacity. But it shows us real simple here. Here's our negative pressure and our positive pressure. And we have an installation manual so that we can check what those pressures are in running, just to make sure that it's doing the full 40% to 100% capacity. Okay, are you ready? This is where we get into like my favorite. And it's just my favorite because I've worked on it for a long time. It's a simple design, and they have changed their design over time. Still same model, different nomenclature at the end of it. So let's look at this Goodman 97. GMVM 97 modulates between 35% and 100%. It has, Paul asked, does the vacuum gas valve give better control than the electronic? That is a wonderful question. I think we would have to have an engineer to be able to dive into that. Although I'm seeing both in these super high efficient units. So it really comes down to how it was designed. I mean, these are all running 97, 98, 98.5% efficient using both principles, using the time-tested vacuum modulated gas valve or using the updated electronic stepper. Both of them seem to be working very, very well. So it really comes down to the manufacturer. So yeah, it is pretty interesting. So let's look at this. If we look at this Goodman 97, we've had two different ones. And here's why. The earlier generation up until I think when Comfort Bridge came out, that was 8 years ago. Around 8 years ago. Comfort Bridge is how I got into this, if you didn't know. My very, very, very first video that I did on YouTube back in 97 or 98 was this. Well, I'm sorry, the next slide. When we went from this to the next slide, when we came out with Comfort Bridge, I did a YouTube video, and me and my buddy at Johnstone an iPhone 7, and that's what started all of this. Just because I thought it was interesting. So here's the earlier model. So this would have been 90 up to, not 98, 18. So up to around 18. This system, let's start on the right. Circulating blower, 1, 2, 3, 4, 5. That's our high power coming right off the inductor coil, just a choke, and low voltage. So I got a true variable speed blower motor. Let's look at the draft inducer. Induced draft blower. I have white, red, black coming back to a 3-terminal junction. And then let's go to the gas valve. My gas valve over here in circle, there's common. There's, I think it's PM. Anyhow, we've got a gray and a brown wire. If we follow those back, it comes back onto our onto our main control board. Same pressure switches, same limits. Like all of these furnaces have the same pressure switches and limits that we use in a single or 2-stage gas furnace. They're just different ratings. If we look at this, we have a variable speed draft inducer and a 24-volt gas valve. When they went to Comfort Bridge, the model stayed the same. The revision went to BA. That's the last 2 letters, BA. AA model of this furnace used the variable draft inducer with a 24-volt vacuum modulated gas valve. When they went to BA, when they went to the Comfort Bridge technology, it still had the ECM draft inducer, constant airflow. It still has the induced draft blower that's variable speed. And it's how we can tell this is true variable speed draft inducer right here on the main control board. Those 3 wires, white, red, and black, go back to the control board and it says UVW. That's our 3-phase designation, just like a inverter compressor motor. So that's a true variable speed draft inducer. But if we look at the gas valve, that has went to our new modulating gas valve. So the Goodman GM-VM 97 and many others from Goodman and Amana. Daikin is similar, but it is a communicating only. We just went from the vacuum modulated into the electrical modulated. Now, boy, I hope I get time to get to these furnaces. We're actually getting close. We only got 15 minutes left. All right, so let's take a look at how we stage, and then we'll go check these out a little bit. If not, we'll get to them another time, but I really hope that we do. If we look at the staging for a modulating unit, we're going to, for this lesson, we're going to stick with the GM-VM97. So that's actually, I have the entire installation manual. That's another really cool thing about all these different camera operations that I have here, is that I can skim through. So this is our smart board behind us. So I got our smart board fed in from a feed. So we can actually use our smart board for all sorts of things. Let me get out of there real quick. Yeah, we'll go ahead and write on it. And we'll pick red. So when we were talking about, let me get out of here. When we were talking about that draft or that gas valve, I guess I should go over here. That is our red, white, and black going to UVW. Oh, I should have changed microphones. I will here in a second. Sorry. That is our true three-phase off from that. So just another neat toy that I have in here. All right, let's get back to it. So when we talk about staging, I'm so glad, Garrett. When we think about this from a big perspective, really think about it. We only have 2 styles of modulating furnaces ever. One of these 2. The only other difference is, does it have a communicating thermostat or a non-communicating thermostat? Yeah, I'm sorry for that. I got a headset that I'm gonna put on here in a second that'll take care of that. I just got excited and forgot about it. So let's look at how we modulate. Let's take that GM-VM97. And we're not going to be using a communicating thermostat. We're going to use a legacy thermostat on this particular setup. Oh, Todd, great question. What about the Daikin? The Daikin is using the true variable. So that last Goodman wiring diagram, it's very similar, but it uses a communicating thermostat only, doesn't have the options. Brian, I'm glad you're enjoying this. Glad to have you here with us. The Goodman went through the 2 iterations, and some of the other manufacturers, you can use a legacy 24-volt thermostat, or you can use communicating. So it depends on the manufacturer. When the Goodman went to the Comfort Bridge, it kept the legacy thermostat for the thermostat and communicating to the outdoor unit. Daikin went communicating into the thermostat and communicating to the outdoor, and uses some slightly different algorithms, but very, very similar. Yeah. Pulse width modulation is the newer variable one. So that is the variable capacity gas valve that's being done by pulse width modulation. So let's say we can use the Goodman. This is a good example because we have our early generation, the AA version that used 24-volt thermostats, and then we have the BA that's still 24-volt thermostats, and then we have the Daikin that uses the communicating. I'm going to show you algorithms for both. And this is very similar to a lot of manufacturers. And I can tell you, out of all of these brands we went through, this is the only one that shows us the actual staging algorithms. That's why I like the Goodman manuals. They give a lot of data and they break it out pretty clean. And some other manufacturers do a great job as well, but I've learned a lot from my Goodman and Amana and Daikin manuals. So let's take a modulating furnace. Let's take this Goodman modulating furnace, and we're actually going to connect this with a single stage thermostat. And we go, how can we do that? Well, algorithms, just like an inverter does. If I hook it up to a single stage thermostat, it needs to light. So all modulating furnaces are going to light at somewhere between 70% and 100% of its capacity. It needs to have higher volume of gas and airflow for proper ignition. So what we do on this one, we raise the draft inducer to 80%. On the earlier model, we just allow the draft inducer to run the valve. The new one, we run the gas valve up to 80% as well. we light, and then we drop down almost immediately down to minimum operating capacity, about 35% capacity. And then after 2 minutes of running at 35, it's going to step up to 57% capacity. It's going to run for 8 minutes. And then it's going to step up, and these are going up at a rate of 1% per second. So to go from 57 to 78, it takes 21 seconds. So it stages up to 78%. It stays there for 10 minutes. If we still haven't satisfied, it's going to go all the way up to 100%, and it's going to stay up there for the rest of the cycle. After 20 minutes, we are running at 100%. And then it records that. It recognizes how long it took to get to those cycles, how long it took to get to 100%, really, is what it was looking at. Or did we satisfy in that first 10 minutes and we only made it to 57%? Because then it starts going, well, 57% is probably a good place to operate at. So that's on a single stage thermostat. What about a two-stage thermostat? Well, a two-stage thermostat, it's going to still use a call on W1. So it's going to run up to 80% in light, drop back down immediately within a few seconds. It's going to run at its minimum capacity, 35%. It's going to run for 2 minutes. It's going to step up to 50, so 15 seconds to go from 35% to 50%. That's 15%, 1% per second. Goes up there to 50. It stays for 8 minutes. And then it runs up to 60%, but then it stays at 60%. Because our thermostat is going to dictate whether it goes to 100% or not. If W1 is the only thing that we get, then it's just going to stay at 60%. And then if it gets to the point where W2 closes because it's ran for a long enough amount of time, it's going to step up. Wherever it's at, it's going to take off. If our W2 kicks in that 2 minutes, that first 2 minutes, it's going to go, oh, we need to be more than W1, so let's go ahead and ramp from 35% to 80%. And it's going to do that in 1% per second increments. It's going to get up there at 80%. It's going to stay there for 8 minutes. And then it's going to step its way up to 90%. And it's going to stay around 90%. After that, if it needs to, it can finish going up to 100% in 1% increments, but it's going to stay there at 90% for about 10 minutes. And it's going to start monitoring that to see how it's actually doing time-wise. Now, what about a communicating thermostat? Let's go step up to the Daikin. Communicating thermostat, they've had two different ones. They've had the generation 1, which is called the CTK01, and then they've had all the new ones, which they go CTK02, 3, 4, and now they're into the Daikin 1 Plus. The cool thing about a communicating thermostat is it has its own algorithms. Standard single stage or two stage thermostat, the only algorithm it has is on or off. With a communicating thermostat, it has its own algorithms and it can manage those 1% increments. It can tell the furnace where it wants to run based on previous run cycles. It builds its own algorithms to understand what is the lowest capacity that I can run and still be able to maintain comfort. So the communicating thermostat does a wonderful job of managing that. So if it was the early generation, it'll fire, it'll drop down to its lowest, and then after 2 minutes, it starts taking demands. Do I need 10%, 20%, 30%, 31%? And it manages through there. With the newer generation, it's based off from how far from set point are we? And that's the nice thing about communicating thermostat as well, is that it knows how far away from set point to decide where should we begin. If I'm 3 or 4 degrees, we're probably going to light off at 100% and stay there. If it's within 2 degrees, it may only go to 50% based on previous run cycles. So that is all of our content for today. So we got a few minutes left. Any questions? We're going to try, I'm going to try my homemade headset. And yes, this is 12 gauge copper ground wire and electrical tape. We're going to try something here. How's the audio coming through for everybody? Check 1, 2, 3, 4, 5. Because what we're going to do is we're going to go over to this modulating gas furnace. And we'll give it just a second, make sure it's coming through. It should be coming through fine, but I just want to make sure. Somebody can let me know in the chat if the audio is coming through okay. Anybody there? I know sometimes takes a second or two. All right, Todd, thank you. We really appreciate that. All right, so we're going to head on over there. All right, so we are going to go take a look at this unit, maybe walk through some steps. Hopefully our audio is working fine. Excellent. Fantastic, Paul. Thank you. So the cool thing about having this studio is that we can work on things all around us. These are just temporary. I just threw them up here. We're actually going to have full-size trainers in here. We're going to have functional refrigeration trainers. We're going to have a bunch of different things to work with. And I'm going to try to keep it modular so that we can bring up what we need each time. That way, depending on what the topic is, we can go back and forth. So when we look at all of our layout, we look at our 80% single stage gas furnace. We look at our modulating gas furnace, not a lot of difference, right? Component-wise, we're still the same. Our 80% uses that single pressure switch, where our modulating gas furnace, this particular one, has 2 pressure switches that it uses for the modulation of our draft inducer. And then it has a third one that is actually for the drain, the condensate drain. So that is just a safety switch in case you get a plugged drain, the water backs up into the secondary heat exchanger, into the collector box, and it just starts shutting things down. So it's only really using the 2 pressure switches. They're all tied together, and that is what's going to feed the signal, is the speed of our draft inducer. So if we fire this thing up, what we're going to see, now I haven't got our motor worked out just yet, but we're going to get there. Hear that? That's for you, Paul. So that was our gas valve stepping closed. So the very first thing that happens is our gas valve steps closed to make sure that it's in the off position. Our draft inducer will start. About E60 is a motor. It's recognizing there's no load on it. So our draft inducer is going to start. Remember, we're going to be up at 80% of its speed, potentially 100, but most likely it's going to be 80%. It's going to go through its standard sequence of operation. I think right now we're on fan, so let me make sure to shut that down. Yeah, that's the reason we got that error code. Let's go through a gas sequence of operation real quick. I was playing with it, trying to get my load to match with our ECM so that we could do a visual for our ECM, but I got to come back to that one. All right, so there again, our gas valve is stepping closed. Oh, quit. Our draft inducer is going to fire up. Put her in heat. I've got me an error code, so I'm not sure what I actually got there. He said I just got this thing up and running today, so maybe we'll do a second one. Oh yeah, we're in gas heat now. So our normal sequence of op. Oh, I know why we are. That is completely my bad. So it went into 100% capacity because it was recognizing flame detected before the sequence. So let's try this one more time and we'll call her a day. By the way, if anybody in your classroom needs to be able to demonstrate flame rectification without flame, I've got a video on how to build those. It's just a couple resistors and a diode to duplicate that. It's around 3.5 microamp DC load that we put across the flame. All right, here we go. Ready? Okay. We're at idle. I've got my temperature set for 74. Let's do 75. We should be getting a call for heat here in just a moment. Not sure what we may have a delay on that thermostat. Nope, there it's calling for heat now. We're in gas heat mode. Our draft inducer is going to do its thing. And it's going to be looking for its capacity. It'll make, oh, it's going through a close. I've got an error code. I'll have to come back to it. Okay, so that's another show. So, any questions before I hop out of here? Looks like we're right about time, and I'll have that modulating gas furnace up and running for us for the next show, and we can dive deeper. Yeah, that's a great comment, Ray. There is, even in some of these gas furnaces, I've seen high altitude settings within the dip switches, just for those kind of scenarios. Okay, well, I think that's it for the day. I truly appreciate everybody joining us. Let us know if there are any topics that you would like for us to cover. Coming into the heating season, there are a lot of things we can dive into, and we really want to make sure we're getting the content out here for you. All right, well, everyone, have a wonderful day, and we will see you all next week on Did You Know, the ESCO HVAC show. Bye, everybody.